Hello, what you're going to be looking at here is AP Dual Credit Psychology Unit 2, Lecture 2 on the nervous system. So this is the second lecture of Unit 2. Now, also, if you are preparing for the quiz, which is parts of the brain and parts of the nervous system, if you're preparing for that, it is not on, this does not cover it. It's not in here. So make sure that you know that. But it is important that you know the nervous system for the tests coming up as well. All right, so this is going to be the nervous system, types of neurons, different nervous systems, etc. So we've talked about the neuron and what it is, the little tiny thing it is, and the neurotransmitters making communications. Here we're going to take a look at the whole nervous system together. This is a shorter lecture. At the end, within it, we'll be talking about mirror neurons. And so if you missed the lecture on this, down below on the website is a video, about a 12-minute NOVA video on mirror neurons you may want to take a look at as well. All right, so when we talk about the nervous system, this is the communication system that goes throughout our body. It consists of all nerve cells that go through the peripheral and central nervous system. Your central nervous system is right here, your brain and your spinal cord. That's it, that's your central nervous system. And your peripheral nervous system is everything that comes in to the spine and up to the brain. So you look at the brain and the spinal cord, specifically the spinal cord, as a, like the Mississippi River, if you would, a huge, huge river of information coming up here and into the Gulf. And these are all the little tributaries that go into it to send the message up. Now, again, as mentioned in the previous lecture, this takes less than a second to make this journey. It takes less than a second, but that's a measurable second, because if you take a look right here, this is a winning catch in a Super Bowl. Hurts me because it's the Steelers. But notice he's got the ball, both feet in bounds, game-winning touchdown reception, boom. But notice the crowd, no reaction, no arms up in the air, because this moment for him to catch it and for them to process it, and I think this guy back here is anticipating it, but nobody's quite had the reaction yet, because this is the moment that it happened. Now he'll do it, it'll hit their eyeballs, and then they'll start to go, you know, once it goes to their brain and they go, it's a touchdown, and they go to the body, put the arms up. It takes a little bit of time, just a little fraction of a second, which again is when you're driving in a car at 70 miles per hour, you're actually 10 feet behind where your car really is. And then the faster you go, you're even further behind. So that's why driving at a reasonable speed is better, because you're not processing it that quickly. And then you get somebody, forget about it if you're driving fast after drinking, because not only, I mean, just to be sober, you're already 10 feet behind. You're drinking and it slows down your neurotransmitters. It slows down your reaction time, and you're almost, it's insane. All right. So when we're talking about neurons again, as mentioned previously, can only fire in one direction. So I've got neurons either going to my body or away from my body. So neurons that are coming to my body right here, these are afferent neurons, also known as sensory neurons. Think of them as afferent, they're going at my brain. Sensory neuron, because they're my senses. When I pick up this pencil and I can feel this pencil, it's a sensory neuron. When I can see this PowerPoint here going into my eyeballs, I am sensing the colors and everything else. It's a sensory neuron. Hearing my voice and it goes into my ear and processing with it, those are sensory neurons that are taking that information in. And it numbers in the millions. So I got millions of these neurons going at my brain, these afferent neurons. Then I also have, going the other way down this highway, I've got what are called efferent neurons. And these are neurons that are dedicated to telling my body what to do. My lips moving right now is because my motor cortex is telling my lips to move and make the pressure and the sounds and everything else. They're exiting my brain, telling my body what to do. When I pick up this pencil and I grab it with my fingers, I am telling my fingers to grab hold of it. I am doing that with efferent neurons. Now, feeling it, those are afferent neurons. But asking myself to pick up the pencil, to write, to talk, to do all these other things, to look over there as opposed to looking over there, those are afferent neurons. Those are motor tasks. So those go from my brain to my body and tell my body what to do. So again, when I feel something, it takes a brief moment to get up there. And when I do something, it takes a brief moment to do it. If you're doing a brain scan of somebody and you ask them to snap their fingers, you will see their motor cortex light up a fraction of a second before they snap the fingers, because that's the message being, well, actually it would be this side, because the left side controls right brain. We'll talk about that in a second. So again, this takes a fraction of a second to do. So millions of these guys coming at the brain, sensing things, and millions of these guys going away from the brain, telling the body what to do, motor neurons. Now, interneurons are neurons that stay within the brain and the spinal cord. And now where we go back here, there are millions of these guys just within our brain and our spinal cord. There are billions of interneurons. And these are everything. These are internal communications, interneurons, internal communication. It's what makes me, or I, if you would. And they go with amazing speed because they're just connected to thousands of others. This is when we create a memory, when we're thinking about something, we're doing math skills, whatever. We're making all these connections to when I've done that math problem before. When is this? How does this go to this? And where's this memory? And da, 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 da. All of those are the interneurons going on within our brain, which happen at a lightning fast speed, lightning fast. So every time we learn something, every time I experience something, there is a physical change going on in my body where more neurons are being connected here, 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 and here, which is creating this moment of time that I am experiencing. We're constantly recording, we're constantly learning, we're constantly making new neurons. Your brain chemistry is not the same at the end of the day as it was at the beginning of the day, because of everything that you've experienced. And then at the end of the day, some of these memories I got to turn away. They're not important. I throw them out. And those are disconnects that happen. So interneurons are billions of these guys going on. So it is up to my brain to interpret sort of what's going on. And what's also important to know is that there's kind of two different hemispheres of my brain, which we'll talk about a little bit further in this unit. But know that the left side of your brain here controls the right side of your body, and the right side of your brain controls the left side of your body. So there's a little bit of a cross wiring that goes on here within our brain. So my left eye, if I were to close my right eye, my left eye sees from here all the way over to here. And then if I close my left eye, my right eye sees all of this. So this right here is seen by both eyes, which, by the way, enables me to see depth as well. And your eyes see two different things. If you put your finger out in front of the screen, there we go, right there. If I put my finger in front of the screen like that, and both my eyes are open, but if I close one eye, there it is, I close the other eye, and my finger seems to jump back and forth, but it doesn't. That's just the perception of my two different eyes. Then what happens is, if you've got a wall or something you're looking at, if you focus on your knuckle, you see your knuckle, but you look through your finger, and your finger will actually kind of become invisible because you're going past it, because your eyes, instead of being focused there, are looking past it. And we'll get to more of this when we talk about vision and sensation and perception and all these other things. We'll talk about the importance of the left eye versus the right eye, etc. But that's what you're used to. You're used to this taking that part of my brain, this with that part of my brain, and then I combine the two and I sort of make things happen. And again, there's 30 billion neurons, 10,000 connections to other neurons, and there's over 300 trillion cortical synapse connections. It's just constantly lit up. And again, we'll also talk about left versus right brain. When it comes to the left is more logical, the right is more creative, but we use both at the same time, which enables us to be sort of a holistic person. Mirror neurons are very, very interesting, because mirror neurons are sort of these newly discovered things where when we see somebody else do something and we have empathy, we sort of are experiencing it ourselves. This was done, I think, in a lab in Switzerland. They were studying monkeys for some reason, and they left the monkeys with the peanuts, and they had a little, they had the neurotransmitters. They had they were reading the brain. They were reading the neurotransmitters to the brain. They had all these little electrodes on the monkey's brains, and they noticed every time that a monkey picked up a peanut, a certain signal was made, and they could get it down to the specific neuron. Every time he picked it up, same signal. And then they were leaving for lunch or whatever, and one of the doctors stayed behind, and he picked up a peanut. And when he picked up a peanut, the monkey did the exact same thing because he saw somebody else pick up a peanut. So seeing somebody doing something and doing something is a very similar pathway. And that's kind of how we learn. We watch somebody else do behavior, then we do the behavior. It's the reason why when you watch a sporting event, your football team scores a touchdown, you feel your arms go up because when they score, you score. They do bad and you feel bad. You know, you get involved in somebody's text messages or somebody's social media account, or you watch reality television or just any other televisions or movies, you know, and you see the breakup go on and you start to cry because that you feel it, you empathize with that. That happening to them feels like it's happening to you. Another person smiles, we're a little bit happier. Another person frowns, we're a little bit more upset. 93% of communication is nonverbal, and we pick this stuff up and we have empathy with others. Now, again, not all of us have it. Some people are psychopaths and sociopaths and someone else is paying, screw it, whatever. But for a lot of us, for most of us, we have this empathy, and some of us are more empathetic than others. So again, when somebody else is experiencing something, we can sort of feel that. We can experience it. We could feel their pain or whatever. And that's what a mirror neuron is. That's why when you're playing the little video game and your little pixelated guy is going through whatever and he suddenly gets hit, you feel like yourself, because that guy becomes you. And you're sort of experiencing his little things going on there. Now, different types of nervous systems. First off, we've got the central nervous system, very easy. It's the brain, it's the spinal cord, it's the Mississippi River right here, just sort of working its way through there. This communication happens almost instantaneously. There's almost no pause in it whatsoever because they're so connected and they're so used to talking to one another and everything else. And the job of the central nervous system is to get information from the entire body up to the brain. Now, if there is damage in the central nervous system, let's say somebody gets damaged right here and this becomes broken, suddenly I can't send signals to my legs and I can't receive signals from my legs. And this is somebody that has paralysis. You know, somebody with paralysis, just the signal does not get sent anymore and it does not get received. They cannot move their legs. Their legs are still healthy. It's alive. It has muscle. It has blood. It has everything going on. I just can't send it the signal to move. And at the same time, when pain occurs within it, I can't feel those sensations of pain because those signals can never make their way up to the brain. They're being sent up the nerves, but since this is damaged, they're not making it past that. There's sort of this gate that is shut that doesn't allow those signals to be sent. So again, the central nervous system, brain, spinal cord. Now, when it comes to a reflex, and again, we talk about how things take a second or whatever. Reflex doesn't take that long. I have a reflex basically to cold, heat, pain. That if I feel intense heat, intense cold, or something painful, I'll sort of take my hand away right away. This person with their finger on the flame. If my hand is in a fire, I don't want to go, okay, just a second, I'll send that all the way up to the spinal cord, up to the brain, and hey, should I move my hand? Yeah, you should move your hand. Okay, I'll send a message down to move my hand. It doesn't make its way up there. Instead, what it does, the signal just gets sent to the spinal cord, and the spinal cord is smart enough to go, get away, stop it. Ouch, that hurts, you know, and hey, you know, that's where we have that sort of instantaneous reaction. When something's too hot, it's too cold, or it's painful, we just sort of react to it. We have that quick reflex. So we make that quick sort of a move there. So that doesn't get processed up in the brain. And again, the more processing that the brain has to do, the slower the reaction. You know, for me to walk doesn't take a lot of processing, it just goes up to my cerebellum. It doesn't come all the way up to the top here. And that's why a lot of times your coach will say, don't think about it, just shoot. You want to think as little as possible. You want to work on your reflexes, your cerebellum, your motor skills, whatever, because when we get into logic, it tends to slow things down. It tends to screw up too. So other things there on reflex, if you want to take a look. Now your peripheral nervous system, so if this the central nervous system is this guy right here in green, the brain and the spinal cord, your peripheral nervous system is everything outside of it, or on the periphery. So here's my central nervous system. On the periphery of the central nervous system is the peripheral nervous system. And within the peripheral nervous system, there are two, well, actually four, but two branches, if you would, within the peripheral nervous system. There's what is called the somatic nervous system and the autonomic nervous system. So let's start with the somatic. This is the skeletal nervous system. This is the nervous system which controls voluntary movements. This is where I tell my body what to do. I tell myself to pick up this pencil. I tell myself to pick up this pen. I tell myself to wiggle my fingers. I tell myself to walk. These are things that I can control. My muscles and everything else. This is somatic nervous system, my strength, whatever. So this is my central nervous system sending messages to my somatic nervous system within my peripheral to tell my body what to do. So things that I am consciously experiencing, pain, whatever, and taking my hand away from it, and things that I am consciously doing, these happen through afferent and efferent neurons. This is my somatic nervous system. So anything where I am able to do things, I'm consciously able to do things, whatever, using my muscles, that's the somatic nervous system. Things that I can consciously manipulate, I can consciously control. Now, on the other side of this is what's called the autonomic nervous system. So this is a whole nother set of efferent and afferent neurons. And these are for things that are automatic, that I cannot consciously control. For example, my digestive system. I can't sit here and go, okay, I just ate a sandwich, start digesting, digest more, digest harder. I can't do that. I can't control my pancreas. I don't know what the pancreas does, to be honest, or my diaphragm or my heart. You know, I can't just say heart beat faster, heart slow down. I can't just, you know, I breathe, lungs breathe fast. I can do that action, but to make my lungs breathe faster or more efficient, or my heart to beat faster, or my blood to flow quicker or slow down, I can't just sit here and go lower the blood pressure. It's all automatic. All right, so these things fall in our autonomic nervous system. And within our autonomic nervous system, it has two main functions, either spend energy or preserve energy. In times of stress, I need to spend energy. So my sympathetic nervous system takes over. And the sympathetic nervous system takes over in times of stress as stress spends energy. This is when I'm like, I'm being chased by the lion. So I need my heart to beat faster. I need to start to sweat because I want to get rid of all this extra heat and everything else going on in my body. So I need to sweat. My heart needs to beat faster. I need to slow down my digestive system because I don't have time to do that right now because I got to spend energy because I'm in a time of stress. Whereas my parasympathetic nervous system preserves energy. Okay, the parasympathetic nervous system goes, okay, I'm safe. I'm not under attack. Let's just sort of lay back and let's have the heart slow down. Let's just go have the digestive system do what it's supposed to do. And its job is to preserve resources. We'll talk about this more when we get to stress. So again, if I see a snake come up to me, my sympathetic nervous system is going to spend energy because I look at this snake as a threat. So again, salivation is going to decrease because the digestive system is not important. My pupils are going to dilate because I need more information to come in. I'm going to start to sweat because I need to reduce the heat as much as possible. The lungs and my heart are going to beat faster. And again, my stomach and intestine are going to slow down because I don't have time to waste on my digestive system. A snake's going to kill me. Whereas if the snake goes away or I deem that snake not to be a threat, suddenly my pupils can go ahead and go back to their normal size. I'll stop sweating. My mouth can go ahead and start salivating again because my digestive system can do what it's normally supposed to do, and my lungs and my heart will beat at a normal rate because now I am preserving energy. So again, the parasympathetic nervous system preserves energy, preserves resources. This is what we want our body to do automatically, but then in times of stress and I need to spend that energy, the sympathetic nervous system takes over. Now, anytime we do learning, we talked about this a little bit with the neuron. The neuron can be connected to 5 neurons, to 50 neurons, to 5,000 other neurons. The more neurons you're connected to, the more likely you are to learn. This is what's known as neural connections. The more connections you make, every time I learn something, you are making more connections. And it's not just I'm connecting this to something I learned in science class. It's the word feedback shows up and you're connecting it to other times where you've used the word feedback. Computer simulation, and you're connecting it to other simulations that you know about. the more connections that you can make, the more likely you are to learn. Remember when we talked about neurons before, we said the message has to come through, let's say it's a power of 15, and it's got to get over here at a power of 15. So if all three of these send the message 15, 15, 15, and then it gets to these two, and then these two send it to that one, and that one sends it to these two, it comes over at 15. If these three send it to all four, who send it to all four, who send it to all three, it still comes in at 15. So whether I get 15 from one or I get 15 from three, it's still the same message of 15. All right, so again, the more neural connections I make, though, if this guy is not only connected to this one, but he's connected to that one, and that one, even though, let's say he's the only one who got the message of 15, they didn't get it, he can send it to all four of them because he's got all those connections. And all four of these will send it, but let's say that it only gets to these two. These are the only two who pick it up. These two don't pick it up for some reason. So both of these are going to send it, and at least one of these three gets it, they'll send it at 15. If two of them get it, it'll be sent at 15. If three of them get it, it'll be sent at 15. It doesn't get sent at 45. It gets sent at 15. So the message from here gets to here more efficiently when I make more neural connections. And every time we learn, we're making more neural connections. And that's why you'll hear me say again and again and again and again, you got to make more neural connections. The more neural connections you make, the better your learning is, etc. Okay? So again, your nervous system here, you get your central nervous system, spinal cord, brain, and the brain is doing all these functions. We'll talk about the different parts of the brain here in a bit. The peripheral nervous system, you've got the somatic, which spends the energy, and the autonomic over here, the somatic, which is the voluntary movement, and the autonomic over here, which is the involuntary movement, which includes the sympathetic, which spends in the parasympathetic, which preserves other information there. So that wraps up Unit 2, Lecture 2. Remember, this is not going to show up on the labeling quiz. You're not going to have to label the nervous system. This will show up on the test that is